Good afternoon. I'm Francois van Heerden again, and we're going to discuss valley climates. I've got still with me this afternoon Nkuli Belot. She's here with me, and we're going to discuss valley climates, which is part of the tertiary winds that we find. Can you remember in the beginning, Nkuli, we said that there's three kinds of circulation that we find on the planet. Can you still remember those three?
I think we said primary was on a global scale.
Fantastic.
And then secondary was across a region.
Brilliant. Can you give me an example of a secondary one that is on a regional scale?
Can we say the Kalahari High?
Okay, just one thing. Remember, the Kalahari High is just a high pressure system, so we're talking about circulation.
I meant to say the Bergwind.
Would
that be?
A Bergwind, perhaps a better example, because Bergwinds are a little bit more localized. So a better example would be my tropical cyclones or my mid-latitude cyclones, because that affects a whole region, while my Bergwinds only affects a small area. So they're very localized. And the same when it comes to valley climates. These are tertiary conditions that we find. It is tertiary circulation, because the tertiary circulation is localized, it's on a small scale, and it lasts for a short while. While if you can think back of tropical cyclones and mid-latitude cyclones, it's over a long period of time. So when we talk about a mid-latitude cyclone, it can easily be days. When we talk about a tropical cyclone, it can easily be days or even weeks. And when we talk about valley climates, we're speaking about a specific evening or a specific day or whatever the case might be. So please keep in mind that tertiary circulation is localized and the time is over a shorter period. So when we talk about valley climates, it's important to understand that we've got a valley here at the bottom. If I can just move back again. I thought I had a pen and I didn't have a pen. If we take a look at this, you'll see there's my valley. So we're going to discuss the climate that takes place there. And if you see this, you'll see that there's a winter sun and there's a summer sun. Now, what do you notice is the difference between the winter sun and the summer sun, except the fact that they're yellow and red? What else can you see then, Nkuli?
The angle in the of the summer sun is bigger, so that tells us that the sun is more direct.
Okay, so if we can use, for example, you often find that people with magnifying glasses will sit in the sun, and what they'll try and get the angle right, and if they get the angle right, it means that it will concentrate the sun. Is that correct? The same thing happens here. So if, for example, the sun shines and it shines at a low angle, like during winter months, it means that the sun is lower. There you can see the sun is lower, while during summer months the sun is higher. So it often feels as if during winter months the sun is in your face the whole time, and it's actually correct because of the angle that's lower. And that has got a serious impact on what happens here at the bottom in my valley. Take a look there. If you follow the yellow one, you'll see that the area all of a sudden during winter is a bigger area. Now, if it's a bigger area, how does this impact on the temperature, Nkuli?
If it's a bigger area, then it's not as concentrated, so it would be colder.
So it will be colder. And during summer months, if you can take a look, I just want to see if I can grab another color so that you can see. If I can just see, where's my... No, I can't find another color now. But if you take a look at that red one there, you'll see that happens during summer months. So it's much more concentrated, and because it's much more concentrated, it means that it heats a little bit more. And because it heats a little bit more, it literally means that our summers are warmer than during the winter. And it's basically because of this that we find here in the valleys. Okay, there's other reasons as well. The sun is further, etc., etc. But the angle of the sun plays a big role here. And when we take a look at the slopes, it's important to see that the slope facing the sun will always be my warmer slope, and the slope facing away from the sun will always be my coldest slope. So in South Africa, for example, my north facing slopes will be my warmer slopes. And those slopes facing south will be
The colder slopes.
colder slopes. So if you've got to build a house on a mountain, and you've got a choice between building it on the northern slope or the southern slope, where would you build it?
I choose the northern slope.
The northern slope, yes, because you would like the heat. Otherwise, during winter months, you'll freeze to death on the southern slopes. Okay. Does that also impact on how, for example, architects design a house in Cooley?
Yes, it does. I think they think about where they position the rooms.
Exactly. So where would they position, for example, the living areas?
The living areas will be on the northern side.
Brilliant. And your bathrooms and your kitchens will be?
On the south.
On the south. Because you don't need the heat there. You've got artificial heat in your kitchen with a stove and everything there. And you've got artificial heat in the bathroom with the warm water that we often use. Okay. So notice how big the difference is between the angle of the sun and the area that gets heated here in the valley. When we talk about inversion, and I'm not going to explain the concept of inversion again, but there's a link between my inversion and my frost. So what happens is, if for example, all the cold air moves further down into my valley and it collects at the bottom of my valley, it means that my valley will be colder than the surrounding slopes. There you can see there's a minus 2 degrees Celsius. And if you go up the slope, you'll see it increases to 1 and 2 degrees Celsius. Can you see that in Cooley? So the cold air will flow from the top down into my valley here at the bottom where I find my minus 2 degrees Celsius. Now here I will find that frost will form at the bottom. What do you call this pocket?
A frost pocket.
A frost pocket. I told you geography is logical. You see, the frost will form in my frost pocket. And if I say that my frost will form in the frost pocket, it means that if, for example, this is my farm, then I've got to plant things there that are frost resistant. Can you think of something that is frost resistant that you would plant there in Cooley?
Apples.
Apples. Well done. An apple a day keeps the doctor away. You are right. So the apples there at the bottom will also grow very, very nicely because it is more frost resistant. And that is why often in your valleys you find that they produce the best apples in the world. If you think of the apples that you get from the Eastern Cape, there's a well-known brand that comes from there and they call it the long kloof apples, which kloof means the valley, and it is literally in the long valley where they've got these apple trees that are growing there, and then they produce apples to the rest of South Africa that we can buy on the shelves. Then we talk about fog, and this term that we're going to use is radiation fog, and it literally happens when the temperature in the valley, remember we said in the valley the temperature drops. Now if it drops to below dew point temperature, that's the important thing, and the dew point temperature is above freezing, the water droplets will condense. That means the water droplets will become like water itself. And that water is then carried in suspension in the air. And that is the fog that you and I see. So one can almost say that in my valleys, it's like having very, very low clouds that are situated there. And that is my fog that I find. So let me explain again. It is when the temperature in the valley drops to below dew point temperature. Now dew point temperature, can you remember what that means, Nkuli?
It's the temperature at which condensation takes place.
Fantastic. The temperature at which condensation begins or takes place. And if that is my temperature, it means where the gas literally goes to a fluid. Now if that is above freezing, it means that the water droplet condenses and it's suspended to form the fog. And that is why, if you take a look at this picture, you can see it looks a little bit spooky there. Okay, that is the fog that you and I often see in the valleys. And when you go down with a motor car or you walk down into the valley, you often see the fog down there, and that explains it. But that also explains why the fog tend to lift from the bottom, because it doesn't lift from the top, it lifts from the bottom. So if, for example, the temperature of the earth starts to heat during daytime, what will happen is, because of the fact that it heats from the bottom in my valley where the earth is heated, it means that that heat is radiated back into the atmosphere and it lifts the fog until the fog disappears. And then we get to valley and mountain breezes. And here you can see, this is daytime. There you can see there's the sun shining, and this is nighttime. There's the moon. Now, during daytime, we refer to these conditions as anabatic winds, and during nighttime we refer to it as katabatic winds. How do you remember that nighttime is katabatic, Nkuli?
I think of katabatic and I think of cats, and cats are awake during the night, so then the katabatic winds will happen at night.
Brilliant. So a cat walks around during nighttime, and because a cat walks around during nighttime, it means that if you hear the word katabatic winds, it means it is nighttime. If you hear the word anabatic, it means it is daytime. Remember, Anna goes to school during daytime, so Anna works during the day, and during the night the cat walks, katabatic. It's as simple as that. And when you take a look at this, you'll see that the anabatic wind is the valley winds. And here you can see it blows from the valley upwards, and that is why it is referred to as a valley wind. This is a mountain wind because it blows down the slope of the mountain, down into the valley. Remember, a wind gets its name from the direction
from which it blows.
From which it blows. So if it blows from the valley, there's the valley, it means it is a valley wind. If it blows from the mountain at the top there, it is a mountain wind. And just to make sure that you can understand it when they give you a different kind of a picture, I've got here at the bottom, very, very small, but this is just an indication how, for example, an anabatic wind can be shown in a different way. Can you see it still rises up the slopes there? So that hasn't changed. And here, during night time, it still comes down into the valley, which is my katabatic one. And this one is my anabatic. That's just a different way to show it. So please remember that in the exam, the examiner can use different pictures, maybe things that you're not used to because you haven't seen that before. But the bottom line is you need just to focus on what is clear in the picture, and then you'll be able to answer all those questions. Then these are a couple of questions that surfaced during the past couple of years to identify an anabatic wind. Remember, you just look for the daytime. And when anabatic occurs?
During the day.
During day. Anna goes to school during a day. And then frost pockets and cold sinking air. That's just a question that was asked on that, for example, and it's important to understand that it is on the valley floor that you will plant your apple trees because they are frost resistant. And then identify the katabatic wind. You look for the night, it occurs during night time, and another name for a katabatic is also my mountain wind. Define the localized wind. The tertiary wind that blows only for a few hours and affects a small local area. Can you remember we discussed that? And then if you can also take a look at the next one there, you'll see precipitation. Forms of precipitation that you find. Now, I can't answer this question because I haven't got the sketch in front of me, but it's important to just look at the sketch or read the case study and take a look at the form of precipitation, because you get different kinds of precipitation. Can you help me with different kinds of precipitation? What's another word for precipitation, Nkuli?
Water, rainfall.
Rainfall, yes. But it's a little bit more than rainfall, is it true? So rainfall is just a small section of precipitation, but there's things that's a little bit bigger than precipitation or a little bit outside of the scope of rainfall. But help me quickly with precipitation. Different kinds. Rain.
Thunder showers. Hail.
Hail.
Snow.
Can't think of what about dew?
Dew.
What about frost? Yes, they are also forms of precipitation. So keep that in mind. But it's important just to take a look at the sketch or read the case study for you to answer that question. Then identify a sea breeze. And if you had to identify, I know that we haven't got the sketch in front of us to identify the sea breeze. But if you had to identify a sea breeze, how will you know what the sea breeze is?
I'll know because there would be a high pressure over the sea and a low over the land.
Fantastic. And the sea breeze will tell you that it blows from the
Sea.
From the sea to the land. And then a sea breeze develops development of sea breezes. There, Nkuli has explained that a high pressure over the sea, low pressure over the interior due to the heating of the land. The air rises over the land and the air moves in from the sea to fill that space. And then the sea breeze and the link with high socio-economic residential areas that were asked last year, and a lot of learners struggled with this question. But this is actually quite easy. Remember, when people living in high socio-economic residential areas, they would always be looking for a nice scenic view. Is that true? A nice scenic view means an area that's got a nice view. So people would like to look at the sea, for example, at the coastal areas. And where they then build their houses is there at the coastal areas. And if they build it at the coastal areas, they get these sea breezes during the daytime that cools them down. So the link between that is the high socioeconomic close to the ocean will experience this cooling effect of the air that moves in from the ocean to the land. And then to identify the thermal belt, is the thermal belt is an internal circulation that takes place, and you often find where in the valley climates where they indicate what the inversion level is and where the air sinks into the valley, you often find that thermal belt there, and that thermal belt is then the temperatures that are higher there than the surrounding areas. I hope that you've learned something from the valley climates, and our next session we will be speaking about city climates.